Hello everyone, myself Harshita. Today my seminar topic is Finite State Machine. Definition of finite state machine. A finite state machine is a mathematical model of combination used to design both computer programs and sequential logic circuits. It consists of a finite number of states and the system transition from one state to another based on inputs. In simple terms, an FSM is a system that can be in only one state at a time, and it changes states when certain combinations or inputs occur. FSMs are widely used in digital circuits, compilers, control systems, and combinational protocols, etc. Key components of finite state machines. Key components of finite state machines. In FSM, there are 5 main components. First one, state. These are the various combinations or modes in which the machine can exist. For example, processing and done. Second one is input symbols. These are the external inputs or signals that cause the FSM to change from one state to another. For example, button press and clock pulse. And third one is output symbols. Output symbols generated based on the current state or the state input. In More, output depends only on state. In Melee, output depends on the state plus input. Transition function. This defines how the machine moves from one state to another. That is del of current state, comma input and next state. And fifth one is initial state, the state in which the FSM starts operating. Final and sixth one is final one is final or accepting states. This is the special states that indicate successfully. Here are the types of finite state machine. Types of finite state machines. Finite state machines are mainly classified into two types, that are More machine and Melee machine. A More machine is an FSM where the output depends only on the current state, not on the input. Characteristics. Output changes only when the state changes. Generally simpler to design. And the second one is Melee machine. A Melee machine is an FSM where the input depends where the output is depends on the circuit state and the circuit input and the current input. Characteristics of Melee machine. Output can change immediately with input. Usually needs fewer states than a More machine. Faster response to inputs. Output machine function of Melee machine, that is output is equals to f of state comma input. Here are the differences between Melee and More machines. Output depends on state in More, and in Melee output depends on state plus input. Output changes in More is on state change. In Melee, immediately on input change. Number of states are more in More. and fewer in melee. Design complexity is simple than melee. Response speed is slower in More mission comparing to melee mission. Although melee and more are the main types, there are some extended types, that is deterministic FSM. For a given input and state, only one next state exists, used on digital circuits and compilers. Number of deterministic FSMs. For a given input and state, multiple next states may exist. Mostly used in automata theory. And next one is synchronous FSM. Synchronous FSM states transmissions occur on a clock signal. And sixth one is asynchronous FSM. Asynchronous FSM states transition occur whenever inputs change. Limitations of finite state machine. Finite state machines are powerful for sequential logic design, but they are also have several limitations. It cannot handle large memory or complex tasks. FSMs have no memory except the current state. They cannot store large amounts of data of reminder long historical, and number of states grows rapidly. For complex state systems, the number of states increases exponentially. This makes the FSM hard to design, draw, and implement. It cannot handle refuses or context dependent inputs. FSMs cannot process inputs the required memory of previous inputs behind the current state. It is difficult to modify once designed. Changing the behavior of a FSM often requires redesigning many parts of the mission. It cannot handle parallel or concurrent events easily. FSMs process one input at a time, so they cannot manage multiple design becomes much more complicated, and it sometimes slow for real time systems. It may if many states need to be checked or transitions are complex, the system may be response fast enough. Limited scalability. FSMs work well from small and medium systems but become inefficient network protocols and complex controllers and large embedded systems. Capabilities of finite state machine. Capabilities of finite state machines. A finite state machine are powerful tools in digital logic and combinations. The major capabilities are: it can model sequential logic circuits. FSMs can represent systems where the output depends on FSMs and depends on the current state and past inputs. For example, traffic lights, vending machine, and washing machine controller. It can recognize regular languages. FSMs can accept or reject input strings that belongs to regular languages, which are defined by regular expressions. Recognizing binary strings with an even number of ones. detecting specific patterns in input streams. It can perform control operations. FSMs are ideal for systems requiring step by step control, such as microprocessor control units, protocol controls, robot movement controls, and it can implement simple counting. FSMs can count up to a limited range by creating different states, that is, different states for each count values. A three-state counter can count, that is 0, 1 to 0. It can represent real-life state-based behavior. FSMs can model anything that behaves in discrete systems states, such as on or off systems, logic process, and elevator controller. It can convert complex behavior into simple designers. FSMs turn complex time-based behavior into state diagrams, state transition tables, and sequential circuit implementations. This helps in easy design and debugging. It is useful in compiler design and pattern matching. FSMs are used in lexical analysis and pattern searching. It is easy hardware realization. FSMs can be implemented using flip-flops, combinational circuits. These are widely used in digital circuit designs. Applications of finite state machines, digital circuit design, control state systems, combinational protocols, and robotic and automation, game development, pattern recognition, vending machines, and finally ambient system controllers. That's it. Thank you.